I want to create an AI that can play 2048 better than most humans can. I've done this before, but it had a lot of flaws to it, so I wanted to try again and make a video out of it. Before we start though, this video was made as part of the Summer of Math Exposition 2. More about them at the end of the video. The first thing I had to do was recreate 2048. I removed all the animations though, so that the program can focus less on moving the tiles and more on actually making the AI do its thing. There's also a bug with the tutorial series that never got fixed, in that when you make a move, it'll spawn a tile no matter what, even if the move doesn't affect the board at all. This isn't intended, and I don't plan on fixing this bug, but what I am going to do is I'm going to prevent the AI from making any move that doesn't directly affect the board position. And speaking of the AI, it's at this point where I decided I would name mine Bill. Before I could start working on Bill though, I needed a way for him to see what was on the screen. The way I decided to do this was to create a 2D array that would essentially serve as a copy of what the player could visually see. I did this by just creating a function that simulates tile spawns whenever a tile gets spawned to the actual board position, and also a separate move function that just works on the array, so that I don't need to take the data from the screen and then program that into the array. The way these move functions work is by first moving all the tiles as far in the direction as they can without mixing them together, then to mix them together, and then to once again move them as far as they can in their direction. After creating a version of Bill that just completely random moves, I decided to make him smarter. On screen right now, you'll see the first version of Bill. The number on the screen represents the evaluation of the position. The way he finds the evaluation is by taking a variety of parameters, multiplying them each by a multiplier, and adding them all together. Whichever move has the highest evaluation is the move that Bill will do, and that will be the evaluation of the position. The parameters I have are whether or not the highest tile is in the corner, which returns a 0 or a 1, how many empty tiles there are, if there's at least one empty tile, which returns a 0 or a 1, how much tiles will be combined from the move, and how much score will be gained from the move. To find what the best multipliers were for each parameter, I created a system where Bill would change his multipliers and find what worked best. Here's a live recording of me explaining it. Okay, so I just made it so that Bill could teach himself to get better at 2048. So what I have is I reset all the multipliers to 0, and they're displayed here. And then what Bill does is he goes through each multiplier and attempts to alter them, either increasing them by 1 or decreasing them by 1. And if that game does better than the Bill's current best score, it will keep the alteration, and otherwise it'll change it. So here, it's trying to lower one empty by 1, because increasing it by 1 made it do worse, but decreasing it by 1 also made it do worse, so now it's just back to 0, and we're testing for the next multiplier. The system seems like it would work just fine, but there's a lot of flaws that prevent it from being consistent. Let's say the highest tile in the corner multiplier, one of the most important multipliers, drops below 0. The only reason this would happen is due to an unlucky game, and it's likely that this multiplier will increase given enough time. Let's say Bill continues getting unlucky though, and every time he attempts to increase this multiplier, the tile spawns make him do worse, and every time he tries to decrease this multiplier, he gets lucky tile spawns and gets a new best score. Eventually, this multiplier will drop to a value like -10. At this point, trying to increase it by 1 doesn't have much effect, as the multiplier will only change by 10%, which isn't significant enough to see much difference in a game where the tile spawns can have such a large impact on the results of the game. Because of this, chances are, the highest tile will never be stuck in a corner, as it'll decrease the evaluation and Bill will likely never have that multiplier go above 0 without getting lucky. This is an extreme example, but similar things have happened during my testing, with Bill's best score sometimes reaching 25,000 but sometimes only reaching 16,000. I ended up making lots of alterations to the way Bill teaches himself in order to make him more consistent. Firstly, I made Bill play 5 games instead of 1, and used the average score from those games to determine if his changes made him better. This made luck a less significant factor. Next, I made Bill change his parameters by a random value within a specified range, so that the parameters are less likely to change by an amount that doesn't have much effect. The range would decrease every time Bill made an improvement so that you could eventually get a precise set of multipliers. Lastly, I made it so that if Bill played too many games without improvement, I would decrease the best score under the assumption that his 5 games that got him there were too lucky and he should have performed worse. You may see from the footage on screen that there are a lot more parameters than before, and that a couple have been removed too. The footage also has a bug with the new best scores aren't kept track of, but this is the only footage I have from this stage of development, so it'll have to do. The removed parameters are the highest tile in the corner parameter and the merge parameter. The merge parameter was removed because it was too similar to the score gained parameter and often didn't do anything for Bill because of that. And the highest tile in the corner parameter was removed because it was replaced with a new parameter, the chain length parameter. This parameter returns 0 if the highest tile isn't in a corner, but otherwise it'll find a snake-shaped chain starting from the highest tile, take each tile in the chain, put them through a function, and then add them all together for the result. This function is on screen now and essentially finds how the tile's value can be expressed as 2 to the n, then calculates 3 to the n minus 1. I'm going to go through each of the other parameters pretty quickly, so feel free to pause the video to try to understand more if you need to. The surrounded tile parameter returns the number of surrounded tiles on the board, tiles who have no neighbors less than 4 times its value. The subchain parameter acts as an extension to the chain parameter, and finds a smaller snake-shaped chain after the first one ends, and uses the same logic as the normal chain to return the value. The chain end parameter returns 1 if the chain ends with an empty tile, otherwise it returns a 0. The second chain parameter is identical to the chain parameter, except it makes a snake shape that goes through 3 tiles before turning around instead of all 4. It also doesn't make use of the subchain parameter, as this can result of sections of the board being isolated from each other. This parameter will return 0 if its result is less than the normal chain parameter's result, and similarly, the normal chain parameter will return 0 if its result is less than this parameter's. The corner progress parameter returns 0 if the highest tile is not on an edge, but otherwise returns a value from 0 to 7 based on how close the tile is to going back to a corner. The logic it uses to find this result is somewhat complicated, and something that I don't think I can explain well. The edge chain parameter acts identically to the chain parameter, but only returns a value if the highest tile is on an edge. One thing to keep in mind is that if the highest tile then goes back to a corner, the chain will only be 3 tiles long, and the second chain parameter will likely be pretty high. Finally, the edge progress parameter returns 0 if the highest tile is not in the middle of the board, and otherwise returns a value from 0 to 2 based on how many empty edge tiles are adjacent to the highest tile. I didn't make this parameter as complicated as the corner progress parameter, because chances are, if you can't get the highest tile out of the middle in just a few moves, you won't have any tile chains, and you're likely going to lose soon, so there's no reason to bother with any super advanced algorithm here. The next thing I did after letting Bill teach himself for a while is implement a Minimax algorithm for him to use. What Minimax does is it takes a game with 2 players and looks ahead with some amount of depth. It'll assume each player is making the best possible moves and will pick which move a player can use at any given time to guarantee the best results, under the condition both players play perfectly. For more information about what Minimax is, I'd recommend you watch the video linked in the top right of the screen as well as the description. It's the video I used to familiarize myself with this method. The video even features code that you can feel free to copy in your programming language of choice to implement your own Minimax algorithms into whatever game you'd like, which is exactly what I did to make my own Minimax algorithm. You may be wondering though, if the Minimax algorithm requires a 2-player game and 2048 is a single-player game, how is this going to work? What I did was that I assumed the tile spawns to be a separate player. This means that Bill will assume the worst possible tile spawn when looking ahead in order to make his decisions. There are some questions to be had here though. For example, if tile spawns are random, would it be more efficient to just find the average evaluation every time the algorithm sees what tiles can spawn? Would it be better to do this but to assume the worst case scenario if it's at least twice as bad as the average? What about 3 times? Can we make Bill teach himself an ideal value for this multiplier just like the rest of the multipliers? These are questions I never got the chance to act upon, because I wanted to finish this video on time, but you can feel free to mess around with these kinds of questions on your own. One thing I did to my Minimax algorithm is the ability to change its depth over time. If Bill is taking too long to make a move, the depth will go down, and if he makes a move too quickly, his depth will increase. I made it so that the depth decreases if the last move took over 1/8 of a second to calculate, and increase if it took less than half a second. At this point, I was confident I was almost done, but I soon figured out that Bill's method of teaching himself wasn't much better than before, and still suffered some of the same problems. This made me rethink how Bill taught himself yet again. The first thing I did was make him play 10 games instead of 5 after a multiplier gets changed. Then, I changed the way Bill tried to change his multipliers.
Instead of changing them by a random value within a steadily decreasing range, I tried increasing one of them by 10, then decreasing it by 10, then increasing it by 5, decreasing it by 5, increasing and decreasing it by 2, then 1. If a change made Bill improve, he would try to make the same change again before continuing the cycle. Another important thing to note is that before each alteration to his multipliers, Bill would reset the change he made before. This is something that was around from the beginning, but I think it's worth mentioning here for clarity. After Bill's cycle ends, he'll start again from 10 with the next multiplier. Bill will also decrease his best score if he gets too long without improvement, similarly to before. In this case, I set it to every time each parameter is tested 5 times without any improvement. After doing that, I made an optimization to the code. I realized that Bill didn't have to test every multiplier, just all but one. If you imagine the best set of multipliers, I'll put 5 numbers up on the screen as a hypothetical example. There's going to be a ratio between these multipliers. If Bill's method of teaching himself works as intended, his multipliers should approach and eventually reach this value. This should still be true if we permanently set one of the multipliers to an arbitrary value. In fact, if we know this ratio and set one of the multipliers to something of our choice, we can fill in the best multipliers for each other parameter. But we unfortunately can't do that and have to just cross our fingers and hope that Bill finds the best set of multipliers. One last important thing to note is that after I finished coding all this in, I didn't have enough time left to change the system again if it didn't work. So if you think the system has a flaw and you think you know how to improve upon it, I would highly encourage you to use the system you thought of and make your own self-teaching AI. So before I get into the results that Bill had, I just want to say that as I was looking through the rest of my video, I realized I forgot to include the adjacent tiles parameter in the section where I talked about all the parameters. Luckily, it's one of the most basic parameters, so I can just explain it here without needing to pull up a PowerPoint. It's just how many sets of neighboring tiles there are whose values are the same. In other words, how many tiles could potentially be combined in the next move. But anyways, Bill's average score was about 30 to 33,000. And his best score was about 60,000, and I should have the screenshot pulled up on screen right now. Yeah, this has been a great experience for me. I'm very proud that I managed to make Bill consistently able to get the 2048 tile, and the fact that you can get the 4096 tile is pretty good. I'll probably continue to work on Bill after like maybe a month or two. I don't want to get too burnt out, so I'm going to be taking a break from him because I've been doing this for the last like 2 months now. But yeah, I really never thought I'd get to this point. When I started 2 months ago, I just thought this would just be another dream I have of getting a video out for this. I didn't think I'd actually get here, and actually, a couple days ago, I was just thinking about that, and I was just so amazed that I managed to actually get this video out. So I'm very proud of this. Even if I don't win this Summer of Math Exposition 2, I'll be pretty satisfied with what I did. And speaking of which, it seems like the Summer of Math Exposition 2 had a focus on collaboration. So I kind of wanted to talk about that here. So usually when I program, I don't really have any good ideas. This is in fun. I did come up with this idea. It was really fun to make. Um, it made me realize that sort of like that programming, it's really fun, but I just can't come up with ideas. So if you're also like that, or you want to program but you don't have any ideas, um, it's always good to get another person involved. Just ask them, hey, do you have any cool ideas we can work on? It can be a friend, a family member, just anybody really. Um, so yeah. Also, I think it's important to mention that I did show everything in my process of making Bill, but I didn't include any of the bugs I encountered along the way. I encountered so many bugs. I wouldn't even be surprised if it was like upwards of 100 bugs. Um, I did manage to catch one on a screen recording though, which I should have on screen. I feel like the fact that I gave Bill some dialogue just makes the bug all the better. But yeah, I'm gonna keep that screen recording for a while. That's for sure. But yeah, I'm very proud of where I got, all the improvement I made along the way. And I'll probably make another video some point in the future. I'm not sure if it's going to be the next installment of Bill or if it's just going to be something completely different. I'll think about it when I get there. Um, yeah, not much else to say. So, thanks for watching. And if you have anything you want to tell me, put it in the comments. Any suggestions for anything you want me to make, also make sure to mention. I already have a couple more ideas, so I might make those into videos and I might not. Who knows?